Thanks for having me. Yeah, I try to explain a little what I mean by educating artist-inventors. I'll start with a quote that was published in a newspaper in Chicago, as it turned out, after I Googled it. So, life is pretty simple. You do some stuff, most fails, some works. You do more of what works. If it works big, others quickly copy it, then you do something else. The trick is the doing something else, and that's what I want to talk about. I guess emerging media is pretty much about that very thing, striving to do that something else. If you really understand emerging media in the extreme, if you go beyond, say, web pages, game development, if you really try to stay at the leading edge of media, then this is really being an artist and an inventor at the same time. That's what I want to focus on. What does that mean, being an artist and an inventor? What does it mean for the curriculum that we have to offer? It's a curriculum for uncharted terrain. Nobody has been there before. We have to provide to the students some means of navigating in uncharted terrain. I'll try to think about what I did in the years 1990 to present date, and this is what I came up with. I guess there's these more or less about 6 aspects that one should be covering when one tries to educate artists/inventors. Virtuality, tangibility, pervasiveness, intelligence, production and usage, and complexity in terms of technical complexity. I try to illustrate that with some actual technology and some examples from projects of my students and me. Virtuality. You see, that's really some ancient media, if you will, an actual mixing desk where every slider, every knob, every switch does some specific thing which it has to do in terms of technology. There's nothing virtual in there. In this case, we already abstracted away just a little. If you look at those push buttons here, those push buttons mimic mechanical push buttons, but actually these are electric switches. They could have been mounted anywhere. They don't need to be here just right below the drive. So that's already a little step in the direction of virtuality. If you look at how the computerized music studio, audio studio looks like these days, you see I'm from Germany, this is Cubase, this is not Pro Tools, pretty much looks the same. It's a digital replica of what we've seen in those old ages in terms of analog electronics. Things get virtual. This could have been completely different, but people seemingly try to stick with what everybody knows. If you look closer at the different effects and synthesizers and whatever the user interface is created for them, you may see something that's like a two-dimensional sketch of how the actual interface looks like. This is something that a student of mine did. That's a 3D model with interactive real-time ray tracing. You see all of these chrome reflections in real time. The shadows are viewed in real time and whatever. You can turn that around. It really feels like the old, shiny, glitzy interface, but with no actual analog electronics behind, just a virtual device. This is really something that is highly abstract. Another student's work, that students try to figure out what ways are being used for graph-based interfaces. Some of you may know, for instance, Max MSP, where you have boxes that you connect with lines, wires. That student looked into how this could be applied in audio processing, audio production, mixing. He looked at actual products and tried to compile the grammar and the vocabulary of the ways in which graph-based interfaces are being used. So that's really highly abstract. Maybe not the summit of all types of virtuality, but pretty virtual. I do see this kind of progression from something that is highly concrete, tightly bound to the actual electronics, mechanics, and whatever, a progression from that to something that's computer-based and decoupled from anything actual. The problem is, how do we teach students to deal with that? You are faced as a designer with an unlimited number of options. How do you navigate in this vast space? What do you pick? What do you leave aside? And once you picked something, as a designer, you have to try and build rules, systems. That's something that's pretty common for graphic artists, to create, for instance, a system of icons that's consistent and intuitive. In this case, we are doing that on a much broader basis. We may have to design gestures. We may have to design some kind of audio-based interactions as a system, as a set of rules. The curriculum should cover that with several examples. You can't cover that on a theoretical basis. You have to have some concrete examples. But I guess the trick would be to learn from such examples how to do that in 5 years from now, how to do that in 10 years from now with some completely different kind of technology. The, if you will, opposite route is tangibility, to make the virtual tangible. Of course, the grand piano is pretty tangible. Then we had these MIDI keyboards, which are still tangible, pretty much look the same like the grand piano. Then, about 5 years ago, everybody had to build some kind of percussion instruments with the Nintendo Wii Remote. This was one of my students' attempt on that, trying to do percussion, a generalized percussion instrument that could mimic also percussion instruments, maracas, doogie-doogie, or rain sticks and whatever, with the help of physical simulation, a physics engine from a game, and with the help of audio simulation. From the same period, how could we create a drum, a malleable drum, a drum that can be transformed in real time? That student used a touch screen, one of the old touch screens, single touch, and MIDI input, percussion input, drum input device. And now you can control the shape of the drum. So this would be the drum. You can control the shape of the drum with your left hand by pulling or pushing the contour line. And at the same time, you can play the drum by using these fields on the MIDI device. And then we use GPU programming, the computational power of the graphics card, to actually create sound from that in real time. So that's something virtual that becomes tangible. These days, of course, no more single-touch screens. Whenever you try to build something for tablets or for mobile phones, you have to think about a vocabulary and maybe a grammar of gestures. How do you, for instance, in this case it was about music software, how do you allow the user to say, go one bar forward? How do you allow the user to say, I want this control to be increased? There is not yet a standard way for doing so, so up to now we have to invent that. This is one student's work who actually tried out which mapping of gestures to standard functions in audio software would work best, and did some user studies on that. So when it comes to tangibility, I guess the curriculum should cover how we, after we made everything virtual, how we go back and make it tangible again. The main goal, I guess, of tangibility is how to make it understandable again, how to allow users to interact with these things, devices, media, you name it. Pervasiveness is pretty related to tangibility. Now that eco-computing is a trend, think about, these are of course the German versions, in the US they look different. Think about thermostats and light switches. What if these become media? What if your environment becomes a set of media? What does that mean? How would you deal with that? This was one thing that I tried. What about using a laser pointer? This is supposed to symbolize the laser pointer. What about using the laser pointer to control LED lights? Imagine you have RGB, full color LED lights scattered around the room. How would you control that? And what I came up with is a set of gestures. You point onto some place on the wall and let the laser pointer move up and down to say, I want more brightness here, or you go in a circle with that laser pointer to say, I want this color to move clockwise in the color wheel. You want red to move to blue, and you want blue to move to green, and so on. So, thinking about that one, how could we possibly turn everything into a medium? Not just the mobile phone, not just a standard computer, how could everything become a medium? What would that mean in terms of the curriculum? We should be discussing that in many different courses. And a more technical question would be, How can we sense from the environment? How can we add all sorts of sensors to the environment? Audio, illumination. Think about sensors that capture the heartbeat rate. And when we've got those data, how could we react to that? So that's really more than just displaying a web page or executing a query on some database management system. With intelligence, I mean the intelligence of the media as such. If you look at standard journals, there's lots of interesting and very intelligent stuff in that journal written on that paper, but the journal as such isn't intelligent. How can we add more intelligence to media as such? Google, of course, goes a long way by trying to figure out what you actually could have meant with a query. This is an attempt of mine to do something more, to go a little further. In typography, imagine you have thousands of typefaces. How could you get an idea of what's in that mass of typefaces? How many black letter fonts are in there? How many italics fonts are in there? This is a way of depicting, in this case, I guess, 2,000 fonts on one single screen. And the trick is to have similar fonts ending up in the same place. You see these four strange fonts, one typeface, these four fonts end up in the same place. These here go together, these go together. So every single character that you see, every single glyph that you see, would be the technical term, represents one single font. And similar fonts end up in the same place. That's a different approach. Rather than listing all fonts, trying to group them by similarity, which requires some kind of pattern recognition, signal processing, machine learning. Returning to audio, this is something that students did, students of mine. This is about getting an idea of sound effects like from film, all sorts of strange noises. What kind of sound effects do you have in a collection? The sound effects are arranged by similarity, and you can say shine a light on these sound effects to have them play back all at the same time. So all of the sounds in this violet disc are played back at the same time, and you get an immediate idea whether these are, say, thunderstorm noises or if it's some crackle noise or musical instruments or whatever. You see, I did really some work concerning how to display the content of music collections. This is work of two other students who equipped Windows Explorer with an icon generator. So what you see here is a collection of MP3 files. Now it's really music, not sound effects, it's really music files. And similar music files end up with similar icons. So these four pieces, for instance, are piano pieces. They get the same greenish, yellowish, spiky icon. And wherever you see such an icon, you know, okay, this is about piano music, classical piano music. That's done fully automated, again based on signal processing, pattern recognition, and machine learning. So the idea here would be to put more into media than just plain content. Can we have more than that? How can we make the computer understand media? Not the human has to understand media, but can the computer as such also, quote unquote, understand media to help the human user? And what I learned, and the students learned, as we did so, one of the tricky issues with that is to let the computer fail gracefully. If you say these 5 songs are rhythm and blues and these 5 songs is techno, mostly that's not correct. Maybe it's just those 4 songs that are rhythm and blues, and the 5th one of these isn't actually rhythm and blues, but is something like jazzy or whatever. Whenever you do these fixed representations saying this is this, then it's really difficult. It's going to be wrong to a huge percentage. So the trick is how to fail gracefully. The computer is not correct all of the time. If you look at what happened here, the trick is simply, if this icon is a little bluish or not that spiky, you can still get away with that. Saying that's almost like classical piano. If you say this is a classical piano piece and it's not, then you don't get away with that. So that's the trick of how to fail gracefully. And of course, how to design information. We saw Tufty in the talk before. What does that mean for gestures, ambient media? What does that mean for pervasive technologies? The production issue. In ancient times, it was pretty easy to produce media and to consume media. You just scratched something onto that stone and somebody came along and tried to understand what's in there. When I show my students tech, I don't know if that's something that's known to you, the engineering students typically should be doing their final thesis with this piece of software, tech, which is, if you will, like HTML decades ago, but still up and alive in the engineering sciences. When students need to do that for their final thesis, they're pretty surprised how complex the production can be of text. Not just open Word and type something, but say this is to be typeset this way, and now turn off the centering. This is the end of the title page, and so on. So even typesetting can become very complex these days. Everybody learned how to work with blocks, I guess, how to deal with comments. When I do my mathematics videos, I had to do much more, and that's what I learned. You can't just get away with doing mathematics videos. You have to have a workflow for doing that. If you really want to do 1,000 of these or more, you have to have some workflow in place that really works without any hassle, a workflow that you can trust. It's not just about doing videos and uploading them. It's about having some piece of software that allows you to create those videos, some piece of software that allows you to edit videos, in this case with speech recognition and all stuff. It's about software that allows you to let the user find specific pieces in those videos. It's about a complete workflow, including the usage. How do you deal with comments, for instance? That's something I'm targeting just right now, after I've got all of the rest in place. How do I deal with comments and feedback, with the social aspects here? So lots of issues, I guess, to cover in the curriculum. When you do a newspaper, when you do a movie, there's a standard workflow in place. In this case, with emerging media, you have to reinvent the workflow for everything that you create. To start with, how do you test something? Then, of course, how do you produce that? How do you keep producing, by which I mean you've got the first issue or the first volume or the first video or the first hour up and running. How do you do the second hour? How do you do the third hour? How do you archive what you've did? And of course, these days, social phenomena. Could you crowdsource anything? How do you react on comments? And who actually is the producer and who actually is the user? Can you design an environment for other people to become producers? Think YouTube, think UJam, this music creation webpage. So can you create something for somebody else to become a producer? Which leads to complexity. Back to letterpress. Even that was complex. How do you prepare the paper? How do you make sure that a line is fully spread from left to right? How do you distribute the ink? Even that was complex. If you go to 3D, of course, from Germany, now I have to show Cinema 4D, not the Autodesk tools. You can easily spend 2 years on learning that software, or the students can easily spend 2 years on learning that software. And another 2 years on learning how to use it like an artist, how to do animation that looks correct, plausible. But when we come to emerging media, this gets really complex. This is project work by some students of mine who tried to create a robot that moves about in some clumsy, likable way. So not a robot that's perfect, but a robot that's somewhat like a human, a robot that has some issues. So this means mechanical design, this means lots of software engineering and even electronics. And that's really complex. So I guess that's pretty much what Inzok also talked about. How do you connect all of that in one single curriculum? Software development, circuit design, and industrial design, and maybe even mechanical design, which leads me to some conclusions here. So I see the issue of dealing with an abundance of options for which we have to create systems and rules. The students should be learning how to create systems and rules in uncharted terrain. They need to create workflows. They can't live with an existing workflow. They have to create their own workflow. And when it comes to interaction with users, they have to observe behavior. Not just count, say, subscription numbers. They have to really do complex observations on what the users do with that type of media. And the most prominent thing, I guess, is this one. The complexity of production is exploding. When you try to do new technologies for new media, things get really complex. The first issue being the range of technology. It's maybe some electric motors, embedded circuits, machine learning, everything connected wirelessly. There's tons of different technologies involved. And there is not a single production tool that covers all of these. When you build web pages, you may simply fire up Dreamweaver and okay, you'll get the job done with Dreamweaver. If you want to create a new game, you may start with some Autodesk tools and then eventually go to Unity. There is a straightforward way of doing that. But when you have all sorts of different technology coming together in emerging media, this gets really ugly. There's no streamlined production tool. That's the first issue I see here. And then when it comes to splitting the work of designers and engineers, the tricky thing is it's very hard to write requirement specs. You do not know upfront what you actually want. There's a rough idea of what the outcome should be looking like. The example at the end of the last talk, the chair or
cake.
The cake. If you want to really hand off work to some engineers who do the technology part, you have to be very, very concrete, and that doesn't work with emerging media. That's the second issue with complexity. And interdisciplinary teams are okay when you've got the time or the money. I tried to create lots of interdisciplinary teams in my work. This really takes time. These teams have to come together, they have to grow together, they have to learn to live with each other. This takes months. If you have to do something within a week, this is really tricky. One key technology trend that helps us, I guess it was also clear from Inzok's talk already, is the DIY culture. You can build very complex devices from wide variety of prefabricated components. For instance, this is a thermographic camera a student of mine built. We took apart an infrared thermometer. This is a part of an infrared thermometer. Added some remote control servos, added some mirrors, and added tons of software, of course. And this is it. So now you've got a thermographic camera that scans a frame in 60 seconds. And the expensive part, if you will, is handled on the computer. It's based on software. This is just DIY equipment. The same philosophy of DIY also works for software. So this is the public domain version, if you will, of Max MSP, PD. You've got lots of devices, if you will. All of these are like black boxes, some kind of devices that are pretty easy to handle from the outside. You just have to connect them. So in the spirit of DIY culture, it's easy to build audio processing applications without everybody having to know how to compute Fourier transforms and how to find the nearest neighbor. All of that is hidden in these black boxes. But there is a catch. When we rely on these DIY resources, you still have to have an idea of what programming, software development is about. You still have to have an idea of what a resistor does and what a capacitor does in electronics, or even a transistor. You have to have some idea about signal processing. What's the bandwidth of a signal? If you filter out the treble or boost the bass, what does that do to the signal? You still have to know about the basic principles to be able to use all those components. And all of these components are just taking you only so far. This is something that I built on my own. The idea is, if this is a fader, like a fader on a mixing desk, could we have some feedback to the user of what's on that specific track? So imagine 30 of these faders mounted next to each other, and the sound engineer, whose fingers are on that fader, should be knowing what this specific track actually plays right at the moment. And my idea was, okay, we add some electrodes. So the finger does not rest on the lever here, the finger rests on those electrodes. And then we feed in some voltage of 200 or 300. This sounds dangerous. It isn't dangerous. If you know your way around electronics, it's not that dangerous. You feel the rhythm of whatever is on the track in your fingertips. And that's something you can't do with ready-made components. That's simply nothing that is pre-built to do that. So there's the Arduino, of course, as Insuk already mentioned. There's the Arduino, but the rest is discrete electronics. And if you do not have, say, 4 semesters of electronics, you can't do that. There is no prefabricated stuff for doing that. So we have to keep in mind, whenever we rely on pre-built, prefabricated components, whether it's in software or whether it's in hardware, that's not going to solve everything. There's still tasks that can't be done that way. It's tasks that require some engineering background more than just connecting pre-existing stuff together. That completes my talk. Thank you.